Good afternoon and welcome to today's energy seminar. Our speaker today is Alex Grant, who's stuck out of state, and he's a principal at Jade Code Partners. If you read his bio, you'll see this is, I think, his fourth clean tech startup. And despite that, he was able to be named a honoree in energy 30 under 30 at Forbes magazine last year, which is pretty impressive. I should at this point acknowledge the person who suggested the last two speakers and this one, Dinesh Moorjani. So I know Alex knows him. He was a kind of early mid-career person in the class last year and has helped us a lot with, refining topics and picking good speakers. And so far we've been extremely successful. So besides getting into Forbes, in this talk, Alex is going to describe another dimension of the kind of battery ecosystem that you've heard about last week a little bit. And if you were here last spring from another speaker on supply chain logistics. From what I understand, Alex is a innovator in the extraction, which I think means mining and processing of lithium, and concerned about doing that in an environmentally sustainable way, but also, as we've heard, that could have implications for international supply chain and international security issues regarding large-scale deployment, particularly of lithium-ion batteries. So I'm quite pleased to announce Alex today as our speaker. It kind of fits in nicely. We will transition from our four clean tech entrepreneur talks at the beginning of the quarter more to policy and systems for the next few seminars. So with that said, Alex, take it away.
Well, thanks so much for the intro. Somehow tell me if you can't hear me correctly. Yeah, so just to start off, the reason why I am not there in person is extremely characteristic, which is that I am working on a lithium brine exploration project in central Nevada, about 8 hours drive from the Bay Area. And a bunch of schedules got mixed up. So I was gonna come back to San Francisco yesterday, but had to stay an extra 2 days, unfortunately.
That's for the audience members who think you're in the casino in Las Vegas. Good to hear you're hard at work.
Oh no, yeah, definitely not at the casino. I'm in Tonopah, Nevada. I don't know if anyone's ever been there. It is a very small town, but it's the biggest town between Vegas and Reno. So it's got a supercharger, which is kind of interesting. But yeah, so I have a very good and characteristic excuse. Yeah, so I regret not being able to kind of spend time with you guys in Meet Space. But if anyone wants to chat later on, I'm very easily found on the internet. So feel free to reach out. Always happy to make new friends and learn about what other people are working on. So that's the frame. I'm gonna share a couple slides with you today that kind of summarizes a little bit about how I think about lithium-ion battery supply chain impact mitigation, and how to really make sure that the energy transition is as worth it, really as much as possible, to make sure that the CO2 emissions in that new paradigm that we're building right now are just as low as humanly possible. And we're able to achieve the deepest decarbonization that the laws of physics allow, without compromising our high quality of life in the next decade. So just really, there you go. So just on my background real quick. So I'm from Canada. I did my undergrad at McGill in Montreal, studied chemical engineering and philosophy in undergrad, mostly focused on wastewater treatment and water chemistry research at universities and at startups in Montreal. Went for a PhD in chemical engineering at Northwestern in Chicago. I was kind of tired of cleaning up other people's messes doing wastewater treatment research, and wanted to help build a new energy system. So I went to study heterogeneous catalysis for CO2 conversion to methanol as part of a solar fuels concept. And when I was there, I built a high pressure, high temperature reactor, designed and built a gas chromatography machine, like really super hands-on, hardcore kind of mini pilot development, and hated it. So I was really not well suited for academia. I was never going to finish my PhD, I don't think, and wasn't particularly happy in the Midwest. So I ended up leaving my PhD with a master's and moved to the Bay Area to co-found a technology startup called Lilac Solutions. So I started working on this company in early 2016. So about six years ago now, kind of wild to think. That was kind of, another nail in the coffin of my PhD, was the opportunity to go help build this company. So Lilac is a lithium extraction technology company that uses kind of novel ceramic ion exchange materials to take lithium out of unconventional natural resources like low-grade brines, like geothermal brines, which you may have heard about in the Salton Sea in Southern California, for example, and oil field brines and other types of resources to make lithium chemicals faster with lower land footprint. And I was full-time at Lilac for about a year and a half, kind of covered in salt, building mini pilot rigs similar to what I was doing in grad school. Fully automated, kind of robotic ion exchange systems to test our technology on different types of brine resources. Left just under 3 years ago in 2019, and kind of accidentally stayed in lithium. One of our customers just kind of wouldn't let me leave. So I ended up starting my own consulting company, which is Jade Cove Partners, which is still kind of my official title is principal of my consulting company. And I've been consulting on lithium natural resource projects all around the world for the last 3 years, and trying to understand, really just ultimately trying to understand how can we make lithium chemicals faster from natural resources, and how do we make them better with lower CO2 emissions, lower freshwater use, lower land footprint, et cetera. That's really been my mission the last couple of years. And a big part of what I've been doing the last couple of years, which I'm going to talk a bit about today, is working with a company called Minviro in London doing life cycle assessment. So 2 years ago, we actually published the first ever life cycle assessment of lithium hydroxide manufacturing from natural resources. No one had ever published numbers on it before. And that became kind of a benchmark for the industry. And we've since done probably between 20 to 30 different natural resource project LCAs for making lithium chemicals. So we've built up, sorry, my mom keeps trying to call me. We built up the best database that anyone has ever had anywhere on the CO2 emissions involved with making lithium chemicals from natural resources. Every single type of resource, every process pathway, every technology you can imagine. So it's been a heck of a lot of fun building that company as well. Kind of along the side, when I have time, I really like doing independent research, and I really like writing. So on my website, if you guys ever want to go check it out, I've published a ton of articles on different topics that I think are interesting. And in those publications, really what I'm doing is like kind of working through topics that I think are true and are interesting or relevant to the energy transition in the lithium and natural resource space, mostly. Also, what I do is make memes. So if anyone follows me on Twitter, you probably saw my memes already. And if you are in the market for more spicy lithium and hard tech memes, like I'm a one-stop shop. So, just, follow me on Twitter and you'll get plugged in. Anyways, this is why we're here, isn't it? So, September 2020 was not a very nice day in the Bay Area. I've been working on kind of energy and climate and water related projects for a decade, like my entire adult life. And in the last, probably 2 or 3 years, two things have happened. One, acute, severe kind of weather phenomena have really ramped up in a big way that I don't think anyone was expecting to happen so soon globally. Of course, I'm sure I'm preaching to the choir here. But two, people also started really caring about climate change like 2 years ago. Like the bankers decided we had to solve climate change in 2020 for whatever reason. So now this is like an incredibly exciting space, and anyone who was already working on it is probably up to their eyeballs in work that they're doing. Why should we solve climate change? Climate change, I think of climate change as kind of a great filter kind of phenomenon. Climate change could really set us back hundreds or, dare I say, thousands of years of in terms of progress on our planet as a species. And I think that's really terrifying. So this is why it's so important to be working on these types of questions and really trying to like solve actual problems. I see, kind of just to start talking about the thing that I'm actually talking about today. I see working on decarbonization of the battery supply chain as really kind of like a 22nd century type problem. Like, we kind of just got the world over the hump of electrifying transport and, trying to now make a lot of batteries. I use the word try because it is of course very hard, but going all the way back up to the mine and pulling out all the fossil fuel infrastructure all the way back up to the mine is really like so much harder than building a battery pilot plant in Fremont or whatever have you. It is such a gigantic global like multi-stakeholder task, and it's really just like a subset of decarbonizing industry in general, right? And decarbonizing kind of all of industry is really important because it underpins our high quality of lives, right? Like it's us rich people in rich countries who are mostly driving climate change. So we need to be able to like produce the things that we need, whether it's materials or energy or whatever have you, in a way that isn't making this happen anymore. So anyways, this is a quote I stole from J.B. Struble from a talk he gave on campus in 2020. I thought it was a great quote. So he said, "The embodied emissions of the materials used to make the batteries are significant and need to be understood. If you were to power all your EV manufacturing using coal, it would make no difference at the end of the day. One thing we did when we built the Gigafactory was to make it all electric. There's literally no natural gas line. So there's little to no local emissions at that factory. When you weave natural gas to your facility, it makes it much harder to chase it out. The emissions all the way back up to the mine are significant too. When we look at terawatt-hour scales of production, we need to make sure we are not creating unintended consequences as we go through the industrial shift. That is why we are in this situation in the first place, and we need to rapidly remediate that." So in this presentation, I'm going to use this quote as kind of a template for jumping off of on each of these 5 different points. So why do the embodied emissions of battery metals matter? They are quantitatively, objectively important if you run an LCA on a lithium-ion battery. So most LCAs I've seen of a lithium-ion cell compared, or kind of an electric vehicle on whatever grid compared to an internal combustion engine, shows something like 50 to 75% decarbonization for the EV versus an ICE vehicle. That's honestly like not as good as you would expect. I mean, maybe other people have different expectations, but it's going to be a heck of a lot of work to kind of overhaul all of our transport infrastructure, and it seems like kind of sad to be doing it for only cutting the CO2 emissions of transport by half. Part of why the emissions of the kind of EV from cradle to grave, or kind of wherever you want to cut off your accounting, is due to the materials used to make the battery, and of course other materials in the car like aluminum and stuff. And something we have found doing life cycle assessment of battery metals in Enviro is that the embodied CO2 emissions of making these chemicals from different types of resources in different ways with different types of energy inputs can vary tremendously. So there are lithium hydroxide products you can buy today that have kind of a 9x difference in their embodied CO2 emissions. That's massive. So those high embodied emission products kind of hurt the CO2, the overall CO2 mitigation opportunity of the electric vehicle, because we're emitting so much CO2 upstream and shifting the environmental burden, if you will. So if you were to choose like just kind of dirty, honestly, quite typically Chinese battery metals versus kind of cleaner, lower carbon ones, the delta in an MC811 cell of the embodied CO2 emissions would be 55 kilos of CO2 per kilowatt hour. At 3 terawatt hours per year, that's equal to the CO2 emissions of Ireland, Switzerland, and Portugal combined. And that's just the difference in the embodied CO2 emissions of battery metals, not even the aluminum in the car. So that's really significant. And for context, you might not have any good data points in your mind about like what is 55 kilos of CO2 per kilowatt hour high or low. There are battery manufacturers who say that they're going to have an embodied emissions of 10 kilos of CO2 per kilowatt hour in their batteries by 2030. That's basically unachievable, and it's definitely not achievable if they don't decarbonize their supply chains. And there's kind of a really interesting conclusion here that I've kind of more operationalized over the last couple of years, which is to realize that really the power to choose those battery metals that goes into the EVs that the rest of us drive is in the hands of a very small group of people, just a couple companies. Helping people understand this is really important for the people making those decisions of what metals to buy. This is, okay, so quote subsection number 2. If you were to power all your EV manufacturing using coal, it'd make no difference at the end of the day. I can't think of any word besides meme because I call everything a meme now. This meme here is from a sustainability report of a Chinese lithium company. I find it very funny that if you compare 2018 to 2019 embodied emissions of their lithium carbonate equivalent lithium chemical product, they reduced it 0.9%. And the bars look like at least 5%, maybe almost 10% of the delta. And this meme was originally green, and I removed the color because I didn't think it was appropriate to use the color green to talk about how much coal and how much energy they're using to make their lithium chemical. The point I'm trying to make is that there's an absolute massive quantity of greenwashing happening in the space, and it's pretty troubling. Does it go all the way to the top? I don't know, but in the lithium-ion battery supply chain, there's historically been a tremendous amount of kind of deception and greenwashing. So I guess I'm kind of used to it now. But I just find it really important to make sure we are actually talking about things accurately, right? That's been a big part of a lot of my publications and a lot of my work. Tesla does not buy lithium hydroxide from Australia, hasn't bought 1 gram of lithium hydroxide from Australia. It all comes from China. And it all comes from that lithium producer in China who's burning quite a bit of coal to make lithium hydroxide. I'll skip this because I don't want to go into it, but basically, I think that emphasis on minimizing CO2 emissions and decarbonization kind of has geopolitical, kind of tangents associated with it. But that's another day. Story for another day. So the Nevada Gigafactory has no natural gas line. Once you start assuming you can use fossil fuels in a battery metal production process, it gets a lot harder to decarbonize it if you're kind of locking yourself in, right? So it's really critical that people who are designing and operating battery metal plants, like lithium chemical plants, for example, like mines, chemical plants, et cetera, need to be very deliberate about the technical decisions they make to achieve decarbonization goals. It's easy enough to greenwash and lie in sustainability reports, but eventually, I hope at least that it doesn't work forever. And I hope at least that investors start to kind of take it more seriously, and I also hope that eventually regulators take it more seriously as kind of as a kind of a securities violation, to be honest, right? But really instead of getting stuck by violating securities laws and having a whole a heck of a lot of problems for management, it's just easier to instruct the engineers to try to minimize their fossil fuel use in their operation, and really make deliberate decisions to do that, right? Just one example of kind of now I guess in a modern sense, kind of a easy way to decarbonize heat, for example, is to use mechanical vapor recompression for steam and for thermal processing, which is useful for a range of thermal processes for converting lithium chemicals and making other battery metals. Because really what it does is it makes it so that instead of burning coal or natural gas to generate all of the steam that you would use in a chemical process, you're now probably 90 to 95% powering steam generation with electricity, which can be much more easily decarbonized than a fossil fuel. The emissions all the way back up to the mine are significant. The mining industry actually knows this. So the mining industry takes decarbonization relatively seriously in a way that I don't think oil and gas does. And the reason why is because it is fundamentally possible to decarbonize mining. So mining does not need to emit CO2 in the process of extracting minerals from the earth and refining them. A great example is electric mining trucks. So a lot of underground mining is already electric. So it's not at all a new idea to electrify, transport of ore in a mine. Kind of some types of mining operations that currently are mostly powered by diesel will eventually be electrified, whether that's through green hydrogen or directly with batteries. And I think it'd be pretty cool if it was directly with batteries and you're mining lithium with a lithium-ion battery-powered truck. It'd be kind of like the lithium's mining itself. So this stuff's happening. It could happen a lot faster. But I just want to make the point that the mining industry is taking this relatively seriously, but there's still a lot of work to do, and you really have to choose decarbonization if you want it. So what happens when we scale up the battery industry, and it's dependent on coal or kind of legacy processes that are less efficient or whatever have you. If you think about that delta CO2 that I mentioned earlier, between kind of a high embodied emissions bill of materials versus a low embodied emissions bill of materials, that delta is basically as large as the entire rest of the CO2 emissions associated with making the battery. So it's huge. Just kind of purchasing decisions can make a huge difference. I've been kind of screaming this from the rooftops for the last 2 years, trying to kind of convince battery and EV industry stakeholders to take this seriously. Part of the issue here that I've noticed over the last couple of years is that EV companies and battery companies are not mining companies, and they don't understand mining and chemical processing for the most part. And what that means is that kind of the EV industry and the battery industry, which has actually relied on LCA for probably at least a decade to understand the CO2 mitigation impact of making electric vehicles compared to ICE vehicles, has been dramatically underestimating the embodied emissions of raw materials, simply because they didn't know kind of what data to collect, really. And they didn't know how to kind of do diligence on their suppliers to understand if numbers were right or not. So the result is that most database values for doing life cycle assessment on batteries are extremely inaccurate. But kind of database values aside, every single battery bill of materials will be different, right? So if I'm a Tesla or a Volkswagen, I could theoretically have completely different suppliers of lithium hydroxide, and that hydroxide can be made in completely different ways. So it's important to kind of take an asset by asset, supplier by supplier look at embodied emissions, and kind of make sure that priority to decarbonize and track emissions kind of goes all the way back up to the mine. So it's kind of shocking, but it almost doesn't matter if you completely decarbonize or completely carbon neutralize a battery manufacturing process, or even cell assembly is not even that important. If you don't pay a lot of attention to the sourcing of your raw materials, it gets completely dwarfed by the embodied emissions of those materials. So this was more geared towards the lithium industry, but really the place that this comment was coming from, why would an EV company care about lithium mining CO2 emissions. The reason why I talk about this pretty often is because in the mining industry, people used to not take upstream scope 3 very seriously. So if I was using sodium hydroxide in a process, for example, I would not report it in my CO2 emissions accounting. But that's not really a complete way to look at things. Like you have to understand your upstream scope 3 at least in kind of CO2 accounting processes. Really quickly, a couple little case studies. So there are reasons to think that the embodied CO2 emissions of making lithium chemicals, for example, is actually going up. So in the last couple of years, there's been a shift to making lithium hydroxide from Australian hard rock processed in China. And that is typically higher CO2 intense than a Chilean brine evaporation process, for example. But there's reasons to think that those embodied emissions numbers can continue going up because grade and impurity profiles of new natural resources that we're tapping into to make lithium chemicals are kind of declining, right? As you develop and produce a lot of lithium from natural resource assets that are already existing, you obviously can't expand them dramatically. You have to tap into new resources. So if you have a kind of lower grade or higher impurity concentrations, you need to plow more energy and more materials into the system to extract that lithium and make a lithium chemical. But there's lots of interesting ideas of how to reduce emissions as well. Geothermal lithium is one. So this is the idea of building a geothermal energy plant kind of combined and co-developed with lithium extraction to make lithium chemicals using direct lithium extraction process. So that's those are super interesting projects. The two main kind of hubs for geothermal lithium historically has been Southern California and the Upper Rhine Valley in Germany and France. But there's activity going on all around the world on geothermal lithium. And then a second little mini case study to share with you is the sedimentary clay natural resources that you can find all the way from the border of Oregon down all the way into Mexico, all across Nevada. There are probably like hundreds of millions of tons of lithium carbonate equivalent stored in clays across the Western United States. There's a couple projects that are in later stages of development, like Thacker Pass in northern Nevada and Rhyolite Ridge in central Nevada, kind of close to where I am right now. These sedimentary minerals are processed using mostly direct sulfuric acid leaching. And there's one little issue when you do that, which is that sedimentary clay minerals tend to have a lot of carbonate minerals kind of mixed in with them. So if those carbonates are not removed, you end up liberating quite a bit of CO2 when you acidify the carbonates mixed in with that mineral. This is something I'm a little bit nervous about. I'm actually not working on many sedimentary clay lithium projects anymore because I find this problem very challenging and semi intractable, especially for lower grade resources. This is this really like underlines for me the importance of kind of understanding drivers of CO2 emissions in a lithium chemical extraction process, and using life cycle assessment to make sure what really matters, because one of these projects could be acidifying a whole bunch of carbonates and releasing 30 kilos of CO2 per kilo of lithium carbonate, but have electric mining trucks and call themselves carbon neutral or something like this. That would be of course completely deceptive. A lot of coal is still used in making lithium chemicals. I think it would be cool if we stopped using coal in making lithium chemicals and all battery metals for that matter. I kind of want someone to like start a movement or something to weed coal out of the battery supply chain, because I think it's absolutely bonkers that this is kind of still going on in 2022. So just to summarize, if we're gonna kind of get past the great filter and be a more advanced alien species and develop kind of a 22nd century battery metal supply chain, everyone has kind of a part to play. So, I've talked a lot about kind of the role that engineers and technologists have here, because I am one of those people. So, won't go too much into detail there. But I would also kind of really emphasize the importance of investors taking this seriously and kind of investing some time and energy into understanding embodied emissions of battery metals. I think it would be fabulous if there was some kind of moratorium in investing in high CO2 intense battery metals. I know that's totally impossible. I mean, no one's going to do that. But obviously, buyers of these chemicals do have some sway over which chemicals end up in their battery. And yeah, I just think like kind of all of these different stakeholders across the battery supply chain have to be using life cycle assessment to understand the embodied CO2 emissions of their product, and make the right decisions about decarbonization to achieve real decarbonization. So yeah, that's that's what I would say about that. So yeah, that's it. That's all I have to say. I welcome your questions. If anyone wants to chat later on, feel free to reach out. You have my email here. I'm very reachable. I might not have time to chat, but feel free to reach out, and hopefully we can link up at some point. So.
Great.
Thanks, Alex, for that great talk regarding your work. I actually find myself wondering exactly what you're doing there, but you probably can't talk about that in Nevada. As a classic rocker, your theme could be the old Who song, "Don't Be Fooled Again." Is that kind of, if I get your drift here? Don't think you're solving a problem that you might not actually be solving.
What am I doing here? So I'm involved with a lithium brine exploration project. So I'm an engineer. I've worked on like tech startups, like living in a city kind of person. I never thought I would be involved with such an early stage project like this. Like literally the problem set that we're working on right now is shooting like sound waves into the earth to figure out where salty water might be, and kind of in what thicknesses and how extensive in kind of XY, and then how many different aquifers you can find all the way down. And then in 2 weeks from now, probably on Valentine's Day, we're gonna poke a hole, and that'll be the first time that we'll know the actual geochemistry kind of as you go down into the earth, which is really what matters. You can take surface samples, easy peasy, but we're gonna have to drill about 1 kilometer deep to understand where lithium could be, kind of going all the way down, and start to understand how much lithium there could be in this particular exploration target, and to understand if we have higher enough grade to extract it economically and build an actual operation that could make lithium chemicals that could go straight into a cathode for a lithium-ion battery. So yeah, it's crazy. It's literally crazy. Like this company I'm involved with is investing hundreds of thousands of dollars, millions of dollars actually, to drill holes in a salty pile of mud to see if there is lithium there. We don't even know how much lithium is there. We don't even know if it's a project yet. So I think it's a lot of fun. I like being out in the desert. I think it's really fun being out here. But it is a truly kind of unprecedented exercise. Like not very many people have worked on anything like that before, where it's so risky, so bonkers. I mean, it's just totally kind of crazy project. But I find that a lot of fun. So.
Okay, now we can take questions from the audience in the room.
If anyone has questions, I'll just bring you the microphone so we can hear you.
So I was intrigued. I guess I see the solution to this problem being entrepreneurs like you on the one hand, and other players, particularly struck the last few years, as you indicated, by the buy-in from the financial community, finance, banking, insurance, and whatnot. And I know even you probably know this, some really recently rolled up investment funds that have a sustainability index kind of way of valuing investments in their portfolio. So the question for me is, are you talking to those guys? I could see them trying to do kind of quick, simple life cycle, but not going as deeply. To what extent are you communicating with that community already?
So the investor sphere is vast, right? It goes way beyond Silicon Valley, and it goes way beyond New York. There are so many people I could be talking to who I'll never be able to talk to, who control significant quantities of capital, which is partly why I publish, actually, really, is to to try to scale up my message and my work, right? But am I talking to them? Yes, a couple. So like, one of my LCA clients is building a spodumene mineral mine in Brazil, and she has BlackRock as, I think, her largest investor in her company, building the spodumene mine to make spodumene concentrate for conversion to lithium hydroxide. And BlackRock has solicited CO2 emission data from my client, and I've helped kind of essentially fill in the Excel sheet of what BlackRock wants, right? So I've had some experience kind of feeding data kind of down the chain to investors to help them understand kind of what my clients' CO2 profiles look like. I've got on my to-do list for tomorrow or the day after filling out a kind of a CO2 emission profile for a major European auto manufacturer. So I have in contact with a couple of really, globally relevant, significant names. I can tell you that really the most sophisticated folks are mostly asking pretty much the right questions. So most of the major European auto manufacturers have internal life cycle assessment teams already. They build their own LCA models. It's like a little academic department within the Renaults and the Volkswagens of the world. And that's actually I find really interesting. So I've been helping those types of folks better understand battery metal processing, because why we've been so successful doing life cycle assessment in this space is because I'm a chemical engineer. We have mining engineers on staff. We have geologists on staff. We're deeply technical in natural resources sector, and kind of legacy LCA practitioners don't have that. So they haven't been able to catch up with us, I guess. Sorry, long-winded answer, but yes, I am chatting to those types of folks. I wish they would. Well, I don't know. I've been kind of surprised on the upside in the last year or two about capital allocation decisions to low carbon projects. I have to admit, in lithium at least. So I don't know. I'm pretty excited and optimistic, to be honest. But I'm sure there's always more kind of permeation of these ideas into the investor sphere that would be helpful. And yeah, actually, you know what? One interesting comment to share before I stop talking. Something I've noticed people chatting about in these topics of natural resource decarbonization and kind of investor kind of responsibility to investors of reporting CO2 emissions and such is poor performing assets like coal mines and things like that are being shifted into the private sector. So private companies are buying coal mines and kind of natural resource assets that have environmental issues, and then just continuing to operate them because they're not accountable to as many investors as public companies are, and they're not as scrutinized. So that's something I'm a little bit worried about, actually, just to kind of tamper down my optimism. And those private companies don't care about optics or having a cute sustainability report. They are just trying to make money. So yeah, that's something to kind of keep an eye on, I guess.
Okay, any questions in the room here? And more. So I'll try another one. So you started with the book with JB Straubel and Tesla, and you got back into Tesla. Now that Tesla's up about $1 trillion in market cap, are you still working with them? And if so, what's the take? I actually have a friend who did with JB an early EV versus internal combustion engine life cycle comparison. And that was pretty advanced in the day, maybe 5-7 years ago, but not as advanced as what you're talking about here. So are you continuing to work with people like that?
So I'm not, no, I just stole JB's quote. That's a great quote. I haven't met JB in person yet. I've had a couple interactions with him. But I don't know, I haven't signed an NDA, I guess. But, I was up at their offices two or 3 days ago chatting about LCA just casually. I'm not working with them directly, but I understand that kind of sophisticated folks like Redwood and Tesla and the Volkswagens of the world are taking life cycle assessment very seriously, principally because they actually do care about decarbonization for the most part. But it's also very soon going to be the law of the land in Europe. to have much more sophisticated carbon emission disclosures on products sold in the European Union. So they're going to be forced to take life cycle assessment very seriously. So I'm kind of almost now over the last 2 years less worried about the Teslas and the Redwoods and the Volkswagens of the world. Because I think those types of folks are doing a pretty solid job on tracking their supply chain CO2 emissions. So.
Yeah, Europe's been big on this, particularly on the finance issue. You probably know the people running the European climate investor disclosure process were the same people that the UK government hired to analyze the financial crisis in 08 and 09. And they were asked at the end of that, what's the next big thing? And this is what they picked. Essentially, financial disclosure regarding both transition risk and physical risk to companies that people are investing in. Yeah. So I think you might find some good allies there as well.
Well, I think greenwashing should be a securities violation, right?
Yeah.
A lie to investors is a lie to investors, regardless of what it's about, right?
Yeah.
And especially if it's related to climate and environmental impacts that a company incurs in making its product, investors need accurate information on that to make decisions.
Yeah.
Because of near future compliance reasons and morals or whatever have you. Oil and gas companies are having the hardest time of anyone, right? They're really squirming, but the amount of greenwashing in the world is really incredible. You see things like blue hydrogen, right? Like I'm very anti blue hydrogen. I think it's an absolute scam. And just for context, if anyone doesn't know, blue hydrogen. So 95% of hydrogen today is made from fossil fuels, right? From coal or natural gas. Blue hydrogen is this idea of making hydrogen from natural gas and then capturing the CO2 and storing it in the subsurface. I see blue hydrogen as an opportunity simply to kind of retain the value of natural gas assets, like natural resource assets, in the share prices of oil and gas companies. That is by far the best explanation of why anyone would want to produce blue hydrogen. I'm just shocked by how often blue hydrogen kind of gets away with calling itself clean. And there's McKinsey reports where blue hydrogen is labeled as clean hydrogen and kind of lumped with green hydrogen made from water and renewables. And it's a crime, really. It's a crime because the CO2 emissions that would result from making hydrogen that could be captured and sequestered are not tracked today, right? So today, when they make hydrogen, they're just dumping it all in the atmosphere. And the methane emissions in the well field of conducting that natural gas from the subsurface to the blue hydrogen plant or whatever plant, whatever you're doing with the natural gas, are also not really tracked very well. So there's just no compliance reason to do blue hydrogen right. And blue hydrogen is just one example. I mean, there's lots of examples like that where it's so obvious that someone's gonna call a product clean or green, and it's gonna end up being a disaster in terms of CO2 emissions. And a lot of folks are kind of sleepwalking into this because they don't really understand the drivers of CO2 emissions, and they kind of overtrust companies who just make kind of simple declarations, right? So yeah, lots of emotions about greenwashing and those topics. I take it very personally, really.
Yeah.
So.
Well, hang in there. I do think there may be some win-wins in here, but if we don't have the right accounting framework and full transparency, we're not going to even see those. So I do agree with that part of it. There's no kind of simple way to do it. It's equally hard to what you're doing to make sure that the bit that you allow is actually going to get you to a better place through the big transition.
Yeah.
So any other comments in the room? I think we can now adjourn. Oh, yes, sir. You want to
Real simple.
Stand one sec.
Who's doing it right and who's trying to do it better for decarbonizing?
For decarbonizing the lithium chemicals, or decarbonizing what?
Just like the battery making process in general. I'm thinking more like specifically towards like EV cars.
Well, I think my clients are doing things right, obviously, but I'm biased.
Of course.
One, huh?
Can you say who they are?
John's asking, can you say specifically?
I'm trying to think if any of my cathode or cell LCA clients are public. One that's public is named Freyr. So they're building an LFP. They're building a cell plant in Norway, which has a very clean grid, so they're off to a good start. But yeah, so we're helping them with LCA on their cell manufacturing process. That's just one of probably 5 different cathode or cell companies that we're working with at the moment that are otherwise confidential. I will, I hinted at one person, one company that was making kind of tenuous claims and has kind of tenuous expectations for their body emissions. And I might as well just name them because I don't really lose anything in naming them. Northvolt in Sweden. Northvolt is the company that they're planning to make cells for European auto manufacturers kind of in the next 5 to 10 years. And Northvolt has published a target of total embodied emissions of 10 kilos of CO2 per kilowatt hour of storage in their cell. I was showing you kind of some of the orders of magnitude of kind of kilos of CO2 per kilowatt hour of raw materials versus cell manufacturing, et cetera. And based on those numbers, where probably the average right now is something like 75 to 100 kilos of CO2 per kilowatt hour for a lithium-ion battery, that's almost an order of magnitude higher than their target. And I'm not aware of Northvolt publishing relationships with any low carbon battery metal producers or developers for that matter. So today I've seen no evidence that Northvolt is doing anything to promote production of low carbon battery metals. And I just find that disappointing, to be honest. Like I'm sure they've kind of got their heads on right. I'm sure that they have an LCA team, so that I know that they must know roughly at least the kind of drivers of emissions of making their product. But what I'm not seeing is their procurement team kind of putting the pedal to the metal and signing actual contracts to buy actual low carbon metals and chemicals. So yeah, that's just kind of like a disappointment name, I guess. So you asked me who's doing it right. I think my clients are doing things right. So hire me to do your LCAs, but I'm joking. If I had to kind of go through the list, I don't know if that's interesting to you guys. Maybe that's excessive, but most of them are kind of doing it right, but not really. But most of them don't, as I said a couple minutes ago, most of them don't fully really understand the embodied emissions of their cell bill of materials. So it's impossible to do it right if you don't understand that. Yeah, I don't know if anyone's really doing it perfectly or kind of up to my expectations, and that's okay. Hopefully some more of them kind of get there in the next couple of years. But yeah, so it's a bit of a mess.
Okay, Alex, at this point, we're just about out of time here, so we'll transition to the up-close personal student session. Thanks very much for sharing your story with you. I think it's a very, very important one going forward with the clean energy transition. Thanks again.
Yeah, thanks for having me. Yeah, sorry again, I couldn't be there. Got stuck out here in the desert, but again, if anyone ever wants to chat, feel free to reach out. So
well, you'll get a few right now.
Cool. Okay, bye.